Good evening. My name is Dr. Arjun. I'm working as a assistant professor in the Department of Chemistry. So today I'll be taking the open elective, that is Unit 5, which is the objectives of this unit is empirical formula, molecular formula. These are all basic. You are going to study the basic of chemistry. Now we are going to determination of empirical formula by mole ratio method and classification of properties, matters, nanotechnology, nanomaterials, and how the nanotechnology is used in the different fields such as medical, electronics, etc. And different types of allotropy. And these are the things which you are going to study in the Unit 5. So first we should know the first topic is empirical formula. What is empirical formula? Empirical formula is the simplest ratio of the number of different atoms present in it. So first I will discuss both empirical and molecular formula. What is the difference you will get to know. And in molecular formula, it gives the actual number of each atom present in a molecule. So molecular formula, it gives exact atoms present and the number, how much atoms are present in the given compound. So molecular formula for water, H2O. For example, here they are given for hydrogen peroxide. See, this is the molecular formula for hydrogen peroxide. So if you want to write this in the empirical formula, you are going to write as hydrogen and oxygen. This is the difference between the molecular formula and empirical formula. In molecular formula, you are going to write exact number of atoms present in the compound. But in empirical formula, you just represent the number of different atoms present. So this is the major difference between the empirical and molecular formula. And next, the molecular formula and empirical formula are not always the same. That is what I have explained here. And the number of atoms given by the molecular formula corresponds to the ratio of multiplied by 2. Means it will be in the multiplication of 2 or 6. So this is the molecular formula of hydrogen peroxide, and this is the empirical formula what you are going to take it. And for determining the empirical formula by mole ratio method, so you will be having the percentage of compounds are given in the percentage. So you are going to calculate the number of moles in that compound. So for that, these are the 3 steps involved in that for the determination. First is the find the number of moles of each element present, determine the whole number of mole ratio, and the use of mole ratio for the subscription of each element in the formula. So here we are going to find the mole ratio. For that, this is the first example where they are given the 36.5% of sodium present and the sulfur present is 25.4% and oxygen is 38.1% in 100 grams of sample. This is the percentage of molecules present in the given sample. So here we are going to calculate the moles, number of moles present. To calculate that, the formula is percentage divided by the molecular weight. This some typo error is there. This one here, the molecular formula for the determination of moles is the percentage, the given percentage. This the percentage of what, sodium. So the percentage divided by their molecular weight. So molecular weight of sodium is what? 36 Na 22.9. This is the molecular weight divided by this gram is not there. This is wrong little. 22.9. So the percentage of sodium is 36.5. 36.5 divided by 22.9. You will get the value of 1.59 moles of sodium. Same that we have calculated for the sulfur also. Your sulfur, it is 25.4%. 25.4% divided by 32.0. This is the molecular weight of that sulfur. If you calculate, you will get the value of 0.79 moles. Same as it is for, if you take it for oxygen, the molecular weight is 16. So 38.1 divided by 16, you will get 2.38 moles. Whatever the compound they are given, we should divide that percentage divided by their molecular weight. You will get the number of moles present in that given sample. So same example, they are given one more example here for, say, see here. Find the number of moles of each element parts. A, sodium 32.38%, and sulfur, which is 22.65%, and oxygen is 44.99%. For same, that molecular weight 22.9 is for sodium, divided percentage divided by molecular weight 32.38 divided by 22.9. You will get the number of moles present in that given mixture. 1.408 moles of sodium present in the given mixture. That is the calculate the mole number of moles. And next is same, one more problem they are given here. Find the number of moles of each element present. So here lead they have taken, that is 38.4. The molecular weight of lead is 22, what, 207.2. So 38.4 divided by 207.4. You will get the moles 0.185. Same it is for carbon and also for hydrogen they have calculated. You have to know, they are given some of the examples here. And next is the empirical formula tells how many atoms of each element are combined in the simpler unit form. That is what simpler unit form means. There will be no exact numbers how much atoms present in that simpler unit. Simpler unit of a chemical formula. So this is the actual number of and the type of atoms in a molecules may not be the same as the empirical formula. So here the empirical formula tells how many atoms of each elements are combined in the simplest unit of a chemical compound. There will, what is the major difference between the empirical formula and molecular formula is, in the molecular formula, you are going to have the exact atomic number, valency, everything. But in the empirical formula, you just represent the atoms present in that. That is the major difference between. And okay, coming to the next is, sometimes the molecular formula is multiple of the empirical formula, and you have to use collected data to calculate. Means it will be in the ratio 1:2. What I told in before, hydrogen peroxide H2O2. So in empirical formula, you are going to write only hydrogen and oxygen. So next is the classification and properties of matter. What is matter? Matter is a substance that occupies physical space and inertia. So here we are going to discuss about the matter. And matter is anything that has mass and occupies space. That you can call it in simple words. So there are different types of forms uh, of phase, such as solid, liquid, and gaseous phase. And these are all substances which can undergo changes for solid, liquid, and gases. Some of which are classified as physical changes and others as chemical changes also, in, such as in the liquid, solid, and gaseous state. So then next is compounds of pure substance that are composed of two or more elements. That is homogeneous, which are having same, and substance such as water, salt, sugar are simple examples for homogeneous mixture. What is the heterogeneous mixture? Which is having, mixture can either be in homogeneous and mixtures are different, which consists of two or more substance mixed together. That is known as homogeneous, which is having same. But in heterogeneous, it will be having a different composition and different matters. So this is the difference between the homogeneous and heterogeneous. And next is the physical property. And physical property, there is one of that can be observed without changing its composition. In physical property, there will be no chemical changes, but the physical property of that atom or molecule changes. In chemical property, is one observed when matter undergoes transformation that results in the change in the composition also. In the chemical property, you are going to see the changes in the chemical composition also. So that is known as chemical property, and there is physical change and chemical change. These are both what I told for physical and chemical properties. Physical change means it changes it does not changes its composition only, the changes the form of matter, but there will be no change in the composition. In chemical change, there will be change in composition of the matter involved. So this is the difference between the physical and chemical change. And the matter which undergo changes, it is important to realize that the ordinary chemical substance reaction cannot be created or destroyed. This matter is convert from this matter can be converted from one form to another form. That is the fundamental law of conservation law. So next, nanomaterials. Nanomaterials are having means nanomaterials which are having the least dimension between 1 to 100 nanomaterials. That are nanomaterials are conventionally defined as the materials which is having dimension between 1 to 100 nanometer, and it can be indicated by 10 to the power of minus 9. So these are the nanomaterials. It can be defined in the one line. And next is the principal parameters of nanoparticles. Uh, it mainly depends on the shape, size, surface, and characterization and inner surface. And it can be encoded by such as aerosols in solid, liquid, and solid in liquid or liquid in liquid emulsion. These are the parameters for nanoparticles, such as nanoparticles for aerosols are should be knowing what is aerosols. Substance kept under pressure and released as a free spray. For example, if you take it an perfume, if you in the spray, it is kept in under the pressure, but when it is released as a spray, that is known as aerosols. And solids or liquid in air, which can be spread, and suspensions solid in liquid, and emulsions which are liquid in liquid emulsions. So these are the nanoparticles. And in the presence of chemical properties of nanoparticle may be modified. Here also it can be modified. In the presence of chemicals, the properties of nanoparticles can also be modified. So nanoparticles having different ways here on interacting with each other. They can remain such as it can be free or it can be in the interaction with different what it can be in it can be free or it can be in the group also. Some of the nanoparticles depending on the attractive repulsive interaction and force between them. These are the characteristics of nanoparticles. And some physical properties of nanoparticles can yeah, materials reduced to nanoscale can suddenly show very different properties compared to when they exist in the macro size. Macro size means it is around 10 to the power of minus 3, and nanoparticles are very minute compared to the macro particles, where nanoparticle size varies from 10 to the power of minus 9. So, uh, it will so when the macro particles are reduced to nano, it may the properties uh, it may vary suddenly of the physical properties such as copper. For example, here they are given copper, which is an opaque substance, become transparent when it is converted to nano size. It may be co- become transparent when the copper is opaque in the macro size, but when it is converted into nano, it will be in the transparent. It may become transparent. So next is the example is the platinum, which is an inert material. It may act also catalyst. Catalysts are uh, increases or decreases the rate of the reaction. It is helpful for the completion of reaction. So catalysts are used, and aluminum, which is a stable material, turns into combustible when it is converted into nano size. So silicon insulators become conductors And here one more example is the gold, which is solid and inert in the room temperature, which is in yellow color. In the micro scale, it becomes liquid when it is converted into nano size. That is one of the good example. And the next is the applications of nanotechnology. Here it is used in the different fields such as electronics. Yeah, seen before it was coming in the memory cards were coming in the big size. Now it has been reduced within 1 centimeter, and it nanotechnology has been infused in the health and medicine, the size of the preparation of the tablets, and also in the medical field such as the instruments where they are using with the nanotechnology, and with the transportation, eh, also with the energy and environment. Here now recent days with the solar cells, everything getting reduced. So, and also with the space exploration. And these are the applications of nanotechnology. And nanotechnology in electronics, how for this they are given in the, these are the points: electronics, health, medicine, transportation, energy and environmental, and space exploration. For each point, they are given in the brief here. And nanotechnology in electronics, smaller size, allow faster processing time. Time for processing will be very fast, and also it consumes less power. So these are the advantage of nanotechnology in electronics. So I am just briefing out. You can go through that in the SLM detailedly, so that some of the points you can write. Uh, Once you read, you can write in your own words. So that will not be a much problem. And next is some of the area under the development, where the recent developments are going in the nanotechnology is improving the display screens now from LCD, LED, and now some more. It has been advanced. So the improvement of display has been taking place using nano gold particles and from carbon nanotubes, and increasing the density of memory chips. Research are developing a type of memory chips with a projected density. And now recent days, from before it was 250 x's MB, 512 MB, in MBs the memory cards were coming, now up to GB, terabytes. The memory can be kept in a single small chip. That is what the application in nanotechnology of the electronics. And integrated nanosensor are used for collecting, processing, and communicating massive amounts of data while minimum size and weight of the power consumption. These are the recent technologies. And reducing the size of transistors used in the integrated circuits. Before, the size of the, even the size of the mobile and TV were very much big compared to the recent days. So the size of the transistors and the chips have been reduced using the nanotechnology. These are the, and coming next to the application in the field of health and medicine. So still now the mankind is fighting against different diseases like cancer, cardiovascular diseases, Alzheimer's, Parkinson, and diabetes, etc. But in recent days, the nanomedicines have played a potential role to enable early detection and prevention to essential improvement in the diagnosis and treatment. Uh, Nanotechnology is playing important role in the diagnosing and treatment of different diseases. So, nano devices can make here recent days it can be used in the sequencing of gene. What you have seen in the COVID-19, the sequencing of RNA has been changed. So, the sequencing of gene can be done using nano devices, and gold nanoparticles tagged with short segments of DNA can be used for detection of genetic sequencing in a sample. So, nanotechnology can help to reproduce or repair the damaged tissue also. These are the advantages of nanotechnology in health medicine. And recent days, carbon nanotubes are used for the mm, function material for the development of advanced biosensors. Biosensors are nothing but they are made up of carbon nanotubes, and these are the devices which uses biological molecules, especially such as enzymes or antibodies, to detect the presence of chemicals. So, biosensor used here, and the probe molecule to serve as a signature for leukemia cells have been identified using biosensors, and the current flow due to hybridization will be through carbon nanotube electrodes, and prototype biosensors as catheter is been developed. Catheter is nothing but the removal of fluid, which is generally used in dialysis. So prototype biosensors have been used for catheter development. And further, next topic is these are the application, and next is the allotropy. What is allotropy? Allotropy is nothing but the different in physical properties, but it is having the same chemical properties. That is known as allotropy, which is having different physical properties. The molecules which are having different physical properties, but same chemical properties are known as allotropy. So, allotropy is the capacity of the element that to exist in more than one form. So, each form of the element has different physical properties, but the elements are identical in their chemical properties. That is what I have told. It is in the same chemical properties, but the differs in physical properties. Some of the allotropies in chemistry are carbon, phosphorus, and sulfur. These are the three types of allotropies showing elements which are showing allotropy. And coming to the carbon, here allotropy of carbon in various type of forms such as crystalline form, amorphous form, and also in the diamond, which is coming to the crystalline form example diamond, graphite, fluorine, and such as amorphous carbon are microcrystalline such as you can see crystalline form means diamond, graphite, and fluorine. Uh, and amorphous carbon is examples such as coal, charcoal, lamp black, and these can mm, this having same chemical properties, but the physical property has been different compared to the diamond and charcoal. So this is the difference in the allotropy. So in diamond, mm, it is a colorless, transparent carbon, and also Each carbon atom is bonded with 4 carbon atoms by covalent bond. So that's why the carbon diamond is very strong. And coming to the next is graphite. Graphite is nothing but it is the crystalline form of carbon. Graphite is nothing but the crystalline form of carbon. So it is opaque in nature. Slipper. Graphite is a good conductor of electricity. And next is fullerenes. It is the allotropy of carbon. It exists in different shapes like hollow sphere and ellipse. These are the allotropies of carbon. And next is the fullerene. Fullerene is nothing but the allotropy of carbon atom. The molecules containing 60 atoms of carbon, and chemical formula is around carbon C 60 atoms means C60. That is the fullerene. And two types of carbon ring exist in it: 5 carbon rings and 6 carbon rings. This is the characteristics of fullerene. And next is the allotropy of phosphorus. So there are white phosphorus, red phosphorus, and black phosphorus. Uh, as I told, allotropies means they are having different physical property, but it having same chemical properties. So it is having different physical properties. You can see it can from the phosphate rock. Uh, Here you can see each phosphorus atom is bonded with 3 p atoms of non-metallic covalent bonds, and it is this is what the example where it is having different physical properties but the same chemical property. The black phosphorus eating here it is having non-metallic covalent bond in the black red phosphorus also. Coming to the black phosphorus, it is having two different types. One is alpha black phosphorus and beta black phosphorus. Uh, These can be produced by heating the white phosphorus at temperature of 473 Kelvin. With a different temperature and with different atmospheric pressure, it can be created. Alpha black phosphorus and beta black phosphorus. And next is the allotropy of 16th group. Allotropy again is having different physical property but same chemical property. Allotropy of 16th group means in the 16th group of periodic table, what are the compound present there? In the 16th group, such as oxygen, sulfur, selenium, and tellurium, polonium, and liveronium are present in the 16th group. So all these elements of the group exhibit allotropy, means all the 16 group elements present in the periodic table exhibit the allotropy. Sulfur exists in number of allotropic forms. Uh, Sulfur defines the term allotropy where existing 3 different forms. This was in the previous we are discussed about the phosphorus. Here we are going to discuss about the sulfur, allotropy of sulfur, where sulfur in the rhombic sulfur, uh, monoclinic sulfur, means this different physical structure but same chemical property. Plastic sulfur. These are the 3 types of sulfur, allotropy of sulfurs. So in rhombic sulfur, it is having the octahedral and alpha sulfur structure. In monoclinic, it is having rhombic form, and in the plastic sulfur, it is having zigzag form of sulfur, that is known as the physical property is in the zigzag form in the plastic sulfur. And difference between the next topic is difference between the polymorphism and allotropy. Here, polymorphism is the same substance with different crystalline forms. Polymorphism is nothing but it is having same substance with different crystalline form. For example, silver nitrate, potassium nitrate, and calcium carbonate. All are having crystalline form with different crystalline form. For example, it exists in two forms, rhombohedral and orthorhombic. This silver nitrate, potassium nitrate, and calcium nitrate. The structures are different but having same chemical properties. And next is the property of polymorphism. Polymorphism, what is polymorphism? It is the substance with different crystalline form. The polymorphism is the phenomena of the existence of the same substance with different crystalline form, and that is known as polymorphism. And the properties of polymorphism is having different shape due to different arrangement of particles. They have different physical properties, they have and also same chemical properties. The main, these are polymorphism and allotropy are same here. And next is the properties of allotropy. Here, allotropies have different crystalline shape due to different arrangement of the particles. Allotropy have different physical properties and also same. The properties again same different physical properties but same chemical properties due to same chemical composition. Why it is having same chemical properties means it is having same chemical composition. The composition if doesn't vary means it will be having same chemical properties. So next is the points to be remembered. These are general topics. What needed to be diamond is the hardest natural substance that occurs in nature. Some of the points are there. You go through this in the SLM. And the next unit that I will be discussing is Unit 8, that is acids and base. Here, acid and base have many uses in daily life and industrial purpose. For example, gasoline additives which are used in phosphoric acid and carbonate beverages, oxalic acid. Uh, these are the examples for acid where oxalic acid generally in daily routine it will be from the vegetables, and spinach is used in the textile industry to bleach the clothes, and glass industries are used hydrofluoric acid to it means to produce the glass. This each is nothing but producing of the glass, and dyes and many other chemicals are made up of sulfuric acid and nitric acid here. These are daily what we are going to use in the daily life, that such as acids or base. And these are some of the examples they are given here. And the water solution of ammonia is used in the household cleaner to make fertilizers and explosives. So the ammonia is used in the making of fertilizers and explosives, and three major different types of acid base have still used. Uh, Here, the first definition was for acid base was given by Svante Arrhenius. There are three different concepts for acid base. First is by Arrhenius theory, and second is Brownstein theory, that is given by Johnson and Brownstein, and third one is Lewis theory, given by Gilbert Newton Lewis. We are going to study three different theories of acid base: Arrhenius theory, Bronsted theory, and Lewis acid base theory. We are going to study in this unit. And the first is Arrhenius theory, where definition of acid base. According to Arrhenius, acid is a source of H plus ions. Acid is denoted by H plus. So it is a source of H plus ions, and the molecular solution that contains a lot of hydrogen ion is known as acid, and acids likes to be donate hydrogen cations H plus, that is denoted by H plus generally, called as protons. Here you can see this one is the H plus. And according to Arrhenius, acid is a source of ion.